Welcome back to part 2 of this series on how to build an infinite auto-running game like CANABALT. Picking up right where we left off, this part is going to cover a few minor things such as your character gaining speed faster and faster and faster throughout this infinite level, and being able to visualize that in the form of a UI that displays how far you've actually run so far. And finally, we'll be able to visualize it even better by incorporating a parallaxing background effect. All right, let's get started. We already have our player script, and we have our velocity here, and we're already using the Y component of this velocity to control our jumps. So now we're going to use the X component of this velocity to control how fast we're moving. Now, in order to increase our X velocity, we'll need a similar variable such as gravity. As gravity acts as acceleration to modify our velocity in the Y direction, we'll have some acceleration variable to modify our velocity in the X direction. Whoa. We'll just call it acceleration. And we can go with the value of 10. And then we'll also incorporate a max acceleration. As to say, this is what we want our acceleration to be kind of out of, because this value is actually going to change. What we're going to do is make it so that our acceleration slows down as we get faster, so that initially we can speed up very quickly, and then as we get faster, it becomes harder and harder to get even faster. Heading over to our fixed update, we want to make sure that we can only gain speed while we're on the ground, because that's when we're actually using our feet in this universe, you could say. So if grounded, just like our jump, we're going to increase our velocity by our acceleration. And then, well, what we'll also need is a max velocity, because we want to make sure that we can't infinitely get fast, because then the difficulty of the game would just get infinitely high to a point where it'd be impossible to control. So let's say max X velocity, and we're going to put something like 100 on that. All right. And then it's greater than or equal to max equals max, right? Now let's go ahead and make sure that we accelerate slower and slower over time. So our velocity ratio is our current velocity divided by our max X velocity. And let's do that before we apply our acceleration. So we'll modify our acceleration. It equals its max acceleration multiplied by the ratio, but as you gain acceleration, the ratio goes from 0 to 1, and we want this acceleration to go from its max to 0, so we're basically going to do 1 minus the ratio, and then that'll go from 1 all the way down to 0. So we're going to multiply this max, which is currently set at 10, and it's going to decline all the way to 0 as we get faster. Let's watch that happen. There's our acceleration just flying down, and there's our velocity flying up, but it's flying up slower and slower as our acceleration declines, right? And it becomes really hard to get, this final 20% of our velocity is much harder to reach than the previous. Okay, so now that we have that in place, technically our character is moving, our player, but we don't know anything about that. So let's actually give him some distance. All right, there we go, acceleration. The distance we've gone so far. Start that off at 0. And then we're going to add the distance outside of is grounded, because we don't care whether or not we're not on the ground or whether we are on the ground. At all times, if we have some kind of velocity, whether we're running or jumping through the air, we're going to be gaining distance. And we're going to just add on our current velocity times the fixed delta time. And that'll take care of that. And just a sanity check. We're going to watch it increase. There it goes. Fantastic. All right. But now we want to actually visualize this, right? So we want to see this distance in the game. So we're going to add a little counter up here that's going to show us exactly what our distance is. So let's add some UI. We're going to add a UI text. There we go. All right. And doing a little setup here. Screen space camera. Pick the main camera. Then we're kind of locked here. And then let's go to this text. Put it up here in the top right. We're going to align it to the right. Vertical center, why not? We're going to make the color of it white. And then we're going to increase the size because we want it to be very important. Let's go ahead and do, that looks like a good size, 38. All right. And we're going to go ahead and say 0 meters. And then we're going to add to our canvas a new script. We're going to call it UI controller to control anything that has anything to do with our UI. All right. So what this thing is going to need is our player. And I like to do this in the awake function, depending on the scenario. But we're just going to grab our player by doing find game object dot find by name player. So it's going to grab this object by this name. Depending on the type of game, maybe you don't want to do it this way, but I think that this is perfectly fine. And of course, we're going to get the component off of this game object. That is the player component that actually has all of our values that we want. And then we're also going to grab our text, actually. Yep, text. This is our distance text. And we don't know what that is because we need to use UI, Unity Engine, .ui. Good. Okay. And this is going to be, we're going to go ahead and label this. We're going to do a similar thing. Distance text. Find distance text. Get component. The text. Got it. Okay. So now, simple enough. Distance text.text equals. We're going to get some distance, and we're going to floor that. Floor to int. Done. Although I think just casting to int would have done the same thing, but regardless, distance plus space m to get those meters. Let's see if everything we did was right. And there we go, going up faster and faster. We're gaining our distance. All right, and we can jump too, the whole time. Okay, but still, yeah, sure, this is telling us that we're getting further, but we still can't really see it, right? So now it's time for some actual interesting visuals. We're gonna add some parallaxing backgrounds. If you don't know what parallaxing backgrounds are, it's basically a very popular technique used in 2D game development where background elements that are further in the distance scroll by slower than background elements that are closer in the distance. So anything close to the foreground scrolls by way faster than anything very far from the foreground. Even though everything is actually flat on a 2D plane, we can visualize that depth with that difference in speeds. So now we're just going to add a few more sprites. So let's go ahead and backgrounds. There we go. All right. Sprite, another square, BG1, and copy this guy, 2 and 3, right? Each one of these is going to have the exact same script, and it's going to be parallax. create and add. Okay, open that up. So basically we're going to need to identify what our actual depth is to know how fast we need to move. So let's say by default we're at 1, which would say that we're of equal depth to the player, right? So we're going to need our player because we need to know how fast the player is moving. Again, awake. There, and then we'll just say equals player dot velocity dot x times, not times, because we're going to do the larger the depth, the smaller the velocity. So we'll just do divided by depth, right? So if our depth is something like 5, we'll have 5 times less speed than the player velocity. And that's fine, and then we just need to move ourselves. And then we'll go ahead, since we're moving from right to left, we're going to subtract that. We're going to go in the opposite direction of the player, and this is going to be our fixed update. We're going to go in the opposite direction of our player to indicate that he's actually moving forward. And let's go ahead and actually make these sprites something interesting and different. Let's make this one like a red in the foreground. This is going to be the closest one. And we have to change this order and layer. I want to give this guy a higher number since it's closer. This one's going to be at 50. And this one's going to be at 0. And this just determines really how they get stacked in the view on top of each other. And then we're going to take the player and give him something extremely large because he's always in the front. All right, so let's take this guy, stretch him out. And we'll make it smaller than the screen so we can actually see the parallaxing effect. All right, and then we have our second square. Again, let's this one. Put it back here. And let's not forget to give it the parallax script. We'll give it a depth of, let's say 5, and then background 3. We'll give it a depth of 10. And then let's see, increase the scale X, scale Y. What do we have here? Maybe these are just really tall buildings in the background. So we can give them a huge Y scale and create just a few of them. And let's make them all a different color. Kind of fade it out because they're far away. Maybe something like that. And give this second layer here some kind of other weird color. All right. In theory, this should all work. And then, last step. We want to make sure that once these guys get to some position that's far enough on this side, that they wrap back around to some position over on this side. So just making this very simple. Let's say this is -50 and +50. So we're just going to go with that. All right, so if position.x is less than -50 equals 50. Okay, so, all right, as you can see, the closer objects are moving faster than the further away objects. -50, something is pretty off there. It's popping in right over here. Negative 50. Oh, okay. It's because they're wrapped in this background object that I didn't zero out. All right, so let's do that. And then we're going to grab all these guys and move them back to where they're supposed to be. Cool, right about there. And I'm actually going to give these guys some more height so that you can't actually see the space behind them. All right, just kind of making up these numbers. Not very important for these objects. All right. Now we're moving. There we go. Still popping in the wrong spot. I love it. Okay. That's because I was measuring the negative 50 and 50 from the original space. So that's not actually what it is. So now it's actually, look, negative 15. Well, let's go by the longest one. Go with negative 25 to 20 to negative 25 to 80. Negative 25, 80. Let's watch it work. There it goes. All right, cool. So we're about to see another one of these further away in the background objects pop in. And now we get some interesting looking depth along with our running. And you can kind of see how this is going to progress as we go. All right, in the next part of this series, we're going to be going over generating the actual platforms that the player will land on and jump off of. And we'll actually be randomly generating those at random heights and random distances away from the previous platform. And we're going to be basing those off of the player and their current values of their velocities. Basically measuring how high can the player potentially jump right now and how fast is the player moving. So not just how high can they jump, but how far can they jump. And then we can randomly generate where the next platform is supposed to be based off of those values so that if you're going faster, you can jump much further to the next one. All right, and finally, of course, thank you for watching this. If you like it, please give the video a like, subscribe to the channel. We just have a few more parts of this series to go, and then we'll be done with our infinite auto runner. Thank you again, and take care, everybody.